Previously on Hand Tool Rescue. Welcome back to part 2 of the steam engine restoration. This is the final part, I promise. We're going to start off with the newly painted and maximally bondoed parts being reassembled so I can start remaking all of the individual bronze and other metal components that are either missing or extremely damaged. The new shaft was made in the first episode, so that has been applied incredibly sensually, and it is good to go. I threaded it with a nice little die on both sides. It was a really weird setup, but I did that off camera because that took, just like an hour in itself. And I'm just setting the screw in there for now. And I can tighten or change the screw at a later time once everything is fully assembled. And that's kind of the theme I'm going with for the entire reassembly here. I'm not going to tighten anything down massively until I know that it is actually going to run, which is a massive mystery at this point. I have a flywheel here that I got off an old tractor implement, and I will literally just find another one to use as the pulley because the ones for this are completely gone for whatever reason. I don't know why. Maybe that also came off when the bronze parts were disassembled for scrap. I have no idea. Now, I put these studs on, but they're too long, and that's because they're the wrong studs, because I am not a smart human being, and I also just straight up forgot, honestly, because I started disassembling this in February, and it is now August, and I did not remember which studs were which, apparently. So I rectify that, obviously, because I need those studs for the chest of the steam engine. And I also shoved in some shims there to keep that Babbitt bearing top piece propped up in its proper position. And those can be removed as it wears down. But it's just a weird design that it actually even has that much distance between the bottom and top bearing caps. Kind of odd in my book, but that's how it was. Now, if you have not noticed, I am making the design choice, because this is my steam engine, to replace most fasteners, almost all of them, with brass replicas. So I think that looks awesome, and I enjoy le brass. It is fantastically sensual, so I'm going to stick with that theme and make this basically a brass, steel, and black looking tool, which I have done before, and it's just something that makes me excited inside for some reason. The extra leftover non-brass fasteners I will save for potentially another restoration if it ever seems to happen. You can see I haven't tightened this down massively. I'm just kind of getting the proper spacing going so I know what kind of shims I need later on. Now we go on to the fabrication section of the video. Right here, I am beginning to make a little, I guess, center bushing almost for the part that houses the bronze components for both the crosshead and for the flywheel. And you shall see that very soon. I am purposely holding this incorrectly in the vise to trigger people as much as humanly possible. Logically, you would turn it the other way so that as it mills away the material, the vise doesn't close it and therefore jam the entire material into the tool bit. But I don't do that because I'm insane. Now you can see the bushing there. That line, okay, that I milled out is so that you can adjust the tightness of this with that top screw and get it perfectly fit around this, which was also newly machined by me in the previous episode. The line does need to line up with that oil hole near the top, so I will spin that later, and it'll be fine. I also made a little custom washer, a little fancy one you can see right there. And that just kind of keeps the actual screw that holds it in place off of the part that's actually moving. So I don't need to worry about that kind of friction there. Now you can see the threaded rods that I'm shoving into things, okay, have also been replaced. Very simply done, obviously. They're just threaded rods that I machined and threaded myself. You could have bought them, but I decided not to. You could also see the new studs are in place, the originals that aren't 4 inches too long. So I'm happy about that now. And I am still not massively tightening these down because too tight and the bearing cap squishes and gets angry. So I need to get the shims in perfect size before I can really tighten anything down. Now, I need to make these pipe fitting, these bronze pipe fittings. The one I'm making right now is for the piston rod to go through, and it will allow the piston rod to go up and down at obviously a high speed, and it will contain a little packing nut as well as packing material. And as you tighten that packing nut, the packing material tightens around the piston rod and therefore seals off the air or steam from escaping out and around the piston rod, which obviously would reduce its power. So it's a very important piece, believe it or not, and it was way too damaged to be reused. So it needs to be fully remade, and it's kind of fun because I don't get to do this too often. But making fasteners is a lot of fun in my book because you get to use the lathe, and you get to use the milling machine, and I get to use my little collet holders there that are currently chucked up, which is probably not best practice, but it is hexagonal, so it perfectly works in my milling machine vise as long as I just take time to stop and rotate onto one of the 6 sides. The part will come out with wonderfully machined 6 sides, and that's what I need. Once I'm done the sides being machined, I'll bring it back to the lathe and then start threading and drilling out certain portions. It was incredibly complex, at least for me. I don't get to do this level of kind of complicated machinery where there's multiple processes and multiple machines that are needed to produce just one part. But that's part of the fun challenge, and I just hope it goes well. I'm tapping it here with a steam whistle. They're very effective. But I'm actually tapping it with a pipe threaded die. So all the threads on these bronze components here are all pipe threads. So they're tapered, so the tighter you screw them down, the more sealing force they have, which is what we want for this application. So you may have not noticed, but I just reversed the actual die from its starting position and threaded it on in that backwards position so that I can eat away at more of the material closer to the flange end, because on most dies one end is tapered outwards. Now we're drilling this exactly as close as I can get to 1/2 inch, which is what the piston rod is going to be. And I actually, I believe, slightly undersized this by a 32nd of an inch. And then I will kind of make it work itself in when I run the actual steam engine, just because I'm super paranoid at this point that my attempt to run this off of air instead of steam will be the downfall of this engine. Because to run it off air, I need the tolerances to be much higher than if I was running off steam, since the steam and oil mixture seal little tiny gaps much better than just air. So I am super worried about that and conscious about that during this entire manufacturing process here. I cannot mess that up. If anything is too loose and allowing some air to leak, this thing is going to immediately not have enough power to even run. So I need that to be exquisite. So I'm doing a lot of kind of just assembly and then letting the machine wear itself into position because of how much I'm worried about that. I'm also using liquid gasket here, which was recommended to me by Keith Rucker. He suggested that because it's going to be air, you really want something like that. Like a usual just little paper seal would be too much, but I would rather just be 100% sure that it's not a concern and seal it up with that liquid gasket. Now I have this massive chunk of cast iron, okay? It is, by all means, almost too massive for my lathe. Probably is too massive for my lathe. It's 18 inches long and 3.5 inches wide, and it's solid. I purchased this off McMaster Car because at the time nowhere local had anything close to this in a quick time. So I'm deciding that this is the material we're going to use to make the piston rings. If you remember in the previous video, the piston rings were completely shattered, so I need to remake them. I took some measurements. I think I know what sizes are supposed to be, but I don't know how close I can actually get with my lathe setup. Like you could see it wobbling here. The chuck itself cannot like support the actual weight of this material. I could have cut it, but I was worried that the second I cut it, I would immediately need it uncut for some sort of project. So I'm trying to save the material as much as possible since it was so expensive. Now these piston rings are thick. These are big, heavy-duty rings. And my plan is, since I've never made piston rings before, my plan is to just make the slit in them, the gap, as tiny as humanly possible with the tools I have. You can actually break these strategically, but I was too nervous to do that. And then you heat them red hot until they fall to the ground. And then at that point, you know that the gap has been set. So by heating cast iron, it will open up into that position. And if it cools slowly, it will stay in that open position. And believe it or not, as brittle as you may think cast iron is, there's a little bit of springiness in the steel that allows this type of behavior or physical property to make piston rings. So, with those made and cooling, I am going to drill out the peened over center piston rod because it is so unbelievably damaged and worn and pitted that we would get no sealing whatsoever out of it. I will drill it out in hopes of just popping it off and not actually touching the actual piston rod, and I think I actually accomplished that because the hole that I do see in the piston here looks like old school machining marks and has a patina and doesn't have, you know, the kind of new machine look. So I think I got it. But putting the rings on is so stressful because if I mess up, they'll just break, and they don't want to move that much because they're cast iron. It's maximum intensity. I dreaded this moment the entire time. And I didn't really make extra because I'm an insane person. and they got on. I honestly didn't believe it. I legitimately thought these would fail because they're so thick that how much flex can you possibly get out of them? But that apparently is the correct thickness for these based on my measurements, and they're on, and I'm done. Never again do I have to do that. Now, I hone the cylinder very slightly, just, you know, just for funsies. You got new piston rings, you might as well hone it, the cylinder. And I'm just trying to check the seal here, and it's pretty good, actually. I thought it'd just, like, fly right through or something because I failed at measuring, but it really wasn't too bad. But the true test is if it runs at all. Because if it's off by even, you know, a few thousandths, you're going to allow air in to the other side of the piston and therefore lose power. So that's great sadness if that's the case. Now, the new piston rod I have to thread on because I don't have a die this size because it's an odd Whitworth thread. It's a 1/2 inch 12 TPI thread, so I'm surprised I don't have that, or I probably shouldn't really, since it's such a long length and I need it perfectly centered, because if this is off, if this piston rod is even angled slightly during the threaded portion, then the crosshead or the piston will also be canted in some direction that we do not want, which would be great sadness. Now, I left this overnight with the piston rings on, and something did something. There's cracks like all around the piston, which is the greatest sadness in the history of time for me personally with a tool. I couldn't believe it. I still don't understand. Maybe they were there and the pressure of the ring squeezing it did something. Really doesn't make any sense, but it exists, so now we're making a new piston. Have I made a new piston before? No, thank you for asking. Do I generally know what I'm doing? Possibly. We'll find out. The proof will literally be if this runs or not. So many fasteners, so much machining, and one chance to see if it works. Now, I polished up the outside of the piston here, just because it's probably easier to do it now than later. And I start making the grooves for the rings, the correct size, and what they're supposed to be in depth. Hopefully it's fine. I'm getting Mega Town wobble going because my cutoff tool is extended to infinity, and the chuck is just not happy with that. Now I have to do this all over again. It's just horrendous. I am like scared to death at this point. Oh, you have no idea. You know, I can't even explain the stress. The stress of it all. Now, I'm literally just going to Loctite this on. This might be blasphemy, but at this point, I am not massively confident that everything is perfect. So I just need one way of removing this, if I ever needed to see if maybe the piston rod is out a few thousandths and now the piston's rubbing against the cylinder on one side too much. I can't guarantee that at this point. So I'm just going to Loctite that on. It's the strongest Loctite that exists. And I'll just leave that. It won't ever get hot enough to have an issue with that adhesion because I will be running this off of compressed air. It'll actually shrink or at the very least get cold, both the piston and the cylinder due to the expansion of the air. So it's quite the opposite. And we'll just see how that goes. Now, with the piston and the piston rod on, I can start working on the actual packing nut and little packing cylinder thing for the packing material around that piston rod. And I did mess up a little bit and ate into the corner here because I am a complete garbage human being. But not to worry, okay, because it doesn't matter. That section is going to be removed anyways on the lathe due to the design of the packing nut, which I have chosen to make very fancy and of my own design. No real reason for why it looks the way it does. I just thought it looked good. Now I need to bore this out, but not all the way through. The other side will have just a 1/2-inch hole in it for the piston rod to go through, whereas this side needs to be bored out and internally threaded to thread onto that other part that we made earlier. This is much easier and less stressful threading system setup here because I at least know it's nice and straight due to the tailstock live center there. It's once again a pipe thread. So I try to go as far as I possibly can because it will kind of taper out at some point. Awesome. So it screws in, you know, like a 1/4 inch, and then it starts getting tight because of the taper thread. So I'm happy with that. I also have to start cutting things off in like the literal most dangerous way. You're never supposed to do this because these parts stick out too far, and I'm getting an insane amount of flex, and it just won't cut at all, and especially not safely. So it was just the lesser of two evils at that point, which looks horrendous, and I'm sure in the comments section of the non-narrated video, there are a bunch of comments right now saying how I am human garbage and don't know anything, and you might be right, but in this case, at least I knew it was wrong. Now, here's the new packing. It's carbon graphite, like soaked, if soak's even the right term, fabric material. And it's specifically made for steam engines, at least that's its application. And I bought the appropriate side off McMaster Car, and we'll see how it does. I need to have it tight enough so that it moves, but not too tight, obviously.
Keith Rucker at VintageMachinery.org. Hello? Eric, how are you calling me on a V? Never mind. What can I do for you? You've got a steam engine that needs to have the crosshead rebuilt. You don't have the bronze shoes. You don't have drawings. All you've got is pictures? And you want me to make new shoes for this thing? I'm going to have to make patterns, send it off to a foundry, have it cast, bring it in, machine it, all to fit a steam engine that I don't even have here in the shop. Yeah, I can do it. That's a piece of cake, no problem. Just send it on down. We'll take right care of it. Yeah, all I need from you is 2 things. You put a description down in your video to my video so folks can go see how I did it. And 2, I want a gallon of that good Canadian maple syrup. Sounds great. I'll be looking out for it.
Sounds great. All right, bye. P.S. My metal planer is better than yours. So now that I have this part in my hands, I need to get it painted like the rest of them. Would love to do Japanning but as previously stated in the first episode, cannot do with the size of my oven, unfortunately. So he did a fantastic job machining this, by the way. It's just awesome. We even had Clark from Windy Hill Foundry actually cast these first out of bronze, and then Keith Rucker completely machined them to spec, and that video is on his channel right now if you want to go see how he did this. It's super cool. He needed the original crosshead here in black to do it so that we had the appropriate diameter and everything exquisite. It was really cool to see him use all those different machines just for what, at least to me, looked like not that complicated parts, but I was totally wrong, and I'm totally glad that he offered to help with this. Now, we make the lubricación like we always do. Never not doing that. And I squeeze this into here, and it is so nice. It wants to slide up and down so bad. But what it doesn't want to do is spin, which is fantastic in one way, in the sense that it's not supposed to do that. So I'm glad that's the case. But the actual cast iron sides there are worn in a specific way that it wants to hold the crosshead in place. So that's good once assembled, not so good during assembly. Now this portion here is the part that I'm just putting in, and it holds the joint that goes through the crosshead that allows the flywheel to transfer the motion from going in a circle to vertically up and down, which is obviously incredibly important for how a piston works. So we're going to do that. And I actually ended up making a custom nut for the back that had, once again, that odd 1/2 by 12 Whitworth thread instead of the usually 1/2 by 13 that you see today. And that was just a fun little project. Another design I just came up with, nothing too fancy. Now, for the lower part of that arm, the part that engages with the actual flywheel, the bronze parts are missing out of that. So there are two halves of what initially start out as a circle that will wrap around or clamp down the shaft that's attached to the flywheel. And that will allow the motion, the circular motion, to transfer up to the crosshead. You'll see what I mean soon, but I'm just flaring this out due to the design that I've seen previously in photos of this exact type of engine in a museum. So I'm trying to get close to that for this look, because at least those looked original, and I can kind of match that as close as I can. Very simple though. These will be bronze. I haven't used brass, I don't think, for anything at this point. The fasteners might be brass, but all the wear components are solid bronze. And it's bronze bearing bronze. It's not just random bronze. So I need to split this in half, and then I need to shape it to exact dimensions, which I'm going to just do entirely on the sander because these parts are incredibly odd to hold in the vise. And you'd think, oh hey, why don't you just use your fractal vise? Well, at this point that didn't exist. At this point the vise was in my shop, or maybe at Jimmy DeResta's shop, and he hasn't sent it over yet. So that's not an option at this point. I'm just going to hand fit these. Not only that, with the hand fitting, the square or rectangle, I should say, that it goes into is not even close to a perfect rectangle in any way. So the angles are all off anyway, so might as well just finesse it into place. And you can see how that motion works and how the little clampy screw makes the clamp, which is very good for clamping. But what I failed to notice is that this nothing stops this arm from moving back and forth on the rod here, which is horrendous and not good because this will just fly off. So I had to remake all of that with built-in flanges because what I thought was an absence of flange in the photos was actually maximum flange. So I somehow got deflanged, and you never want to get deflanged. So now that I've been reflanged, we're good to go. See? Now, I made another one of these in the exact same fashion, except this is with a smaller pipe thread. And this goes into the chest and holds the rod in place that is connected to the valve. And this is obviously another very crucial part that needs to maintain its exquisite verticality in all directions so that we don't have uneven wear or worse, an improper seal. If the valve does not seat onto the cylinder in the best way that it's ever been seated, then we will have mega leaks, and once again, it shall not run, which is, of course, great sadness. Not only that, it needs to be timed properly. So here is the valve, okay? Now, I have lapped these surfaces exquisitely with my diamond stones, both of them, so that I couldn't notice any leakage whatsoever. There's also a somewhat of a preload that you have to put on this where the rod that you're attaching, you kind of want it to press against that valve, which pushes against the cylinder spaces there, allowing the air to flow in. So there's even more of a seal pressure being applied. And I will time that. Now, I can take this off. I'm not supposed to, but I can take it off if the timing's wrong. But I believe I have timed it exquisitely. And if that's not the case, then I can take off the whole front portion there and liquid gasket and just redo it. Now, I also made these mahogany strips that I wanted. I had this idea for a while, and I wanted to see if it would look good or not. So I quickly did a mock-up using scrap mahogany, and then I really liked it. And I wanted it to look kind of like a barrel, but with the gapping. I need the gapping in there for if I do ever run enough steam, release some heat there. If it was completely encased in wood, it'd probably overheat really quickly. So it needs to have those gaps, and I think it looks cool because mahogany with cast iron and brass, and it is fitting of that era. And hopefully you do as well, but I don't know. It's just a design choice. Now, this is the exhaust and drainage for the cylinder if I did ever run it on steam. But more importantly are the massive amounts of brass oilers that I'm applying to this. I am going for the maximum tool record that I've ever achieved with brass oilers, okay? We got close sometimes to this, but I don't think anything is going to reach this level of brass oiler in a long time. It's so exciting for me because I just like brass oilers are just the coolest. Way too excited about the brass oilers, as you can tell. Now I found another pulley. This will be much better than that other weird flywheel thing at actually transferring power. And you do need a flywheel for this thing to actually function due to momentum. But besides the point, I've also purchased a steam whistle off of a guy who makes them in his shop, and these are really nice, really cool. They're all brass and copper, and I'm really, really pumped to see, or I guess hear this, and what it actually sounds like, since I had no idea until I try and at least turn this thing on. But step one, there's never enough oil. Step two, apply more oil. There's so many oil spots that I'm sure I probably forgot more. It's just, it needs all of the oil. Even the floor it's sitting on needs oil. I'm gonna set this to maybe one drop a minute. That's probably still too much, honestly. But I'm only running this for a little bit. But the moment of truth, my children. My brain in this moment is exploding. It seems to be timed somewhat well. It's making that chugga chugga sound, which is key to properly timed steam engine, apparently. But the true test is how slow can I get this to run? The slower I can get it to run, the better of a job I did at manufacturing things to tolerances and sealing them off. And I think that's pretty good. I don't really know what, I'm supposed to expect since I've never done this before. But this was an amazing learning experience. It is super loud. And the steam whistle's even louder. But it's so much fun. It's so addictive. It's too much fun. It's too much fun. And I tried to put a load on it just with my hands, like really hard pushing down to see if I could stall it. And I actually couldn't really stall it with just like one hand. I probably need two hands and like really commit, but that's dangerous, obviously. So it's probably around the 1 horsepower that the documentation kind of seems to suggest. Anyways, that project is just mind-blowing. And I'm so happy it's done, and I can't wait to see what comes up next on the next videos. It's just such a big project. Thank you all for watching. Later.